All right, we are live.
Awesome. Okay, does anybody have any problem with the reading?
Not really. For me, it was kind of like it was a little complicated to grasp at first, but then once I realized like we were just finding the standard deviation for it's like the sub level of data or however you can explain it. Once I figured that out, it kind of clicked. I was like, oh, that makes sense. So we're just taking the derivative of the collective means, basically. Oh.
Yeah, it was fine. Same thing. It took me a couple times to read it because we're finally getting into like new information.
Right.
But after that, it was fine.
Yeah, same. It's just of understanding what we were doing. Okay, well, let's get into the assignment. Okay, randomly select 5 of the 30 salaries and compute the mean. So you said you just use random.org?
Yeah, I just used that and came up with 5 numbers and chose those because I was at work, so I had like the opportunity to rip up a piece of paper.
Okay, so I'm just running through. I got 12. 24, 23. 5, is that right? 11. And 16.
What was
okay?
So we weren't supposed to pick any specific ones, right? We were just supposed to pick 5
random ones.
Okay.
Yeah.
Okay. Well, my mean was 4,000 or 46,600 with the 5 boxes that I chose.
Calculating mine right now.
So I got, Garrett, what would you say yours was? 46.6?
46.6, yeah.
And then I got 46,080.
Okay.
I'm punching mine out right now. Okay. 49,560.
Yeah, I don't think they're supposed to be the exact same.
Yeah,
because we've taken.
There is no right answer.
Right. It's just depending on which ones you guys got. But they're supposed to be relatively close to each other, which they are. They're within, 100 or so.
Yeah.
So
all right. So this graph illustrates the distribution sample mean. There are 142,506 possible combinations of the 30 salaries. This graph represents the distribution of all the samples. Make a mark on the horizontal axis to indicate the value of your sample mean from part A. Okay.
And then part C says Does your sample mean appear to be unusual? Explain why you think it is or is not unusual.
No, because it's within one. I would say it's within one. Shoot, what's the word?
Standard deviation.
One standard deviation from the center.
Yeah, I put that it wasn't unusual, but because it was close to the actual mean of the graph, because in the reading it said that the sample mean and the standard deviation, or sorry, the sample mean and the mean of the standard deviations should be relatively close as you
Gotcha.
get larger numbers. That makes sense. And if it was way off of the like the center of that graph, then I would say yeah, unusual, because it was way different from the sample mean. If that makes sense.
Yeah, I put something similar, but basically kind of boils down to plain man's language. It's right near the middle.
Right.
All right. Do you compare your mean with question 7A to the mean obtained by at least 3 other individuals? Well, we're doing 2. In practice, you only get to see the mean from the sample you draw. You do not get to observe any other mean that have occurred. So we're all pretty close to the center.
Right.
All right, 8. The Graduate Management Administration Test, GMAT, is used to administer criterion in many Masters of Business Administration MBA programs. The scores of the GMAT are normally distributed with a mean of, I forget what that symbol is, 529 with the standard deviation of sigma 113. Consider a simple random sample, or n is equal to 10 students taking the GMAT. A, what is the shape of the distribution of the sample means for each sample? This is where
So when I go ahead.
No, nothing. Go for it.
What were you gonna say?
Go ahead. I was just thinking out loud. Go for it.
So I put bell-shaped and symmetrical because when I put it into that calculator thing that we got from this reading from chapter, that kind of makes a second graph depending on distributions. I got a bell-shaped figure, but I guess that's not what they were looking for exactly. Because the question just kind of confused, because it says, what is the shape of the distribution of the sample means for all such samples? And I was thinking the graphs, right? What did you guys put?
I got the same.
Yeah, I got a bell shape.
Yeah, because I got the same, and I put symmetrical and all that, but the answer key says normal. So I didn't really know how does that work.
Like, I wonder if it's normal because it's symmetrical, like bell shaped symmetrical versus being
in the reading
left side or right side favored.
Oh, you know what? Yeah, because because when you play with it, you put the normal, the uniform, the skewed, or the custom in that calculator, and so that's what they were going off of. Not okay. That makes sense.
Yeah, and normal distribution does. Oh, it's the same thing, just different wording. Okay, how do you distribution of the sample mean has this shape? We graphed it. I mean, it's normally distributed, like it's Is that what the wording was in the reading? Oh, I closed it. Never mind. I don't have that.
Yeah, it was basically like the parent population's normally distributed.
Okay. All right. What is the mean of the sampling distribution of a sample mean score? Wow, that is okay. Distribution of a sample mean scores for all such samples. I don't even understand the question. Hold on. Sampling distribution of sample mean scores for all such samples. Oh, we're trying to figure out a formula here, right?
No, it gives it to us in the reading.
Does it?
Yeah. It's basically just saying what's the mean.
Oh, 529 then. Okay. What's that symbol called again?
I don't remember.
Yeah, I don't either. What is the standard deviation of the sample scores? This is where it's like, hold on.
It's the sigma over the square root of n.
That one.
Yeah, I forget what they called that equation.
That's the law of large numbers, right?
I believe you are correct, sir.
$13.
Well, the law of large numbers just states that as n gets larger, the sample mean will get closer to the actual population mean. But I think it's the equation for, here in the reading, it says the distribution of sample means. So it's
I got 35.73373756. So I put,
Yeah, that sounds right.
yeah,
Yep.
35.7. Is that what you're putting? 734? Should we always do to 3 decimals? I never know when teachers want that.
I always do 3 unless it states otherwise in like the quizzes or whatnot, but general rule for statistics or for this class was basically just put in the up to the 3rd, unless they say like the 10th or 100th, because they've had some of those that in the quizzes that specifically state like put it only to the 10th, or put it into percentage form or whatever. So I just
Gotcha.
kind of try to go off what they've got.
All right, should we do the quiz?
Yep.
Yeah, let's do it. Okay, question 3. When you're taking sample size of n equals 5, do you guys have it open?
Yeah, I'm
Yeah.
working on it now.
Oh, okay. What is the shape of the distribution of means histogram when the parent population is a right skewed?
Wouldn't it be skewed right? Am I reading this wrong? I mean,
Well,
So this is where I always got confused, because I felt like it right skewed meant that the graph was left skewed.
well, we're not, because
yes. What it means is there's data on the right that is throwing off the entire study. So it's right skewed. So it's going to be pushed to the left because of obscure data on the right.
the little tail goes out to the right. That's how
Yeah, it's dumb.
But
So it's
wouldn't
Go
it
ahead.
be normal? Because if you're looking for the distribution, so your standard, your mean will always be the same right? And so if you get 100 billion samples of 5, right, of sample size of 5 of the same thing, they'll still have relatively the same means throughout every sample that you take. So wouldn't it still come out as a normal distribution?
Right, but remember, we don't have 100 billion samples to work with. We only have one sample of 5. Like, unless it tells us, because it talks about in the reading, unless it tells us otherwise that we have more than one sample, then we only have our sample. So this, I would assume that we only have, because it says when you're taking a sample of 5, what is the...
So then it would still be right skewed, right? Because all that information would fall towards the left side, even though there's outliers on the right hand that are relatively small. Is that what you guys are putting, right skewed? Or skewed right?
I'm not sure.
I'm thinking skewed left, because if your mean is to the left and you have a couple numbers to the right that's skewing the data right, the majority of your mean would be to the left.
When?
I'm trying to go back to the reading to see if it talks about anything more about it.
I'm not seeing anything that's skewed. Hold on. Maybe I'm spelling skewed wrong. Yeah, I'm not seeing anything. Hold on. Okay, here's some of the reading. To the right of the histogram, hold on. We assume that they are known. To the right of the histogram of the parent population is a drop-down menu that allows you to choose the distribution. Normal, skewed, or uniform. Yeah, that's the only. Hold on. That doesn't help us. All right, step 9. These are still just instructions. Right, skew distribution, repeat.
Mm-hmm. Oh, careful. So,
if it's at least 30, it says we'll assume that it's approximately normal. Where it's less than 30, so I'm seeing when is whatever x, the line over at normal, 3.1 in the reading,
right?
The very last one for tremendously skewed distribution. Larger sample will be required before the distribution of a sample mean is approximately normal. Billions of observations used to determine if a particular sample size is sufficient. For this course, if the sample size is at least 30, we will conclude that the sampling distribution is of X will be approximate, but that doesn't tell us what to do if it's skewed one way or the other.
So I went back to one of the previous readings, and it says when the majority of the data falls to the right of the mean, the distribution is said to be skewed left.
Right. That's correct. But so rereading question 3, it almost sounds like it's not just a one sample that we're taking, but the sample size is 5. So we're taking instead of taking 100 out of 100, we're taking 20 samples each with the size of 5, if that makes sense. Because you can't have a distribution of means unless you have multiple means to go off of. Does that make sense? Because if you just take one sample, your mean will be the same throughout both the sample means and the population mean will be the same because you're only getting one mean. You have to take multiple to even do a distribution of means, if that makes sense. So are we allowed to use the sampling distributions calculator?
I believe so.
Okay. So I'm going to draw a right skewed graph with the mean and sample number 5. And I'm just going to put in a couple things here. Clear all those. So yeah, it depends on how many samples we go to. Because if you do only a few, if you only do, you know, about 10 samples of 5, you'll get a similar shape, like a right skewed shape. But if you do a large number of samples, it'll come out to be a normal distribution.
Well, right. The more samples you do, the more normal it's going to be. I'm not sure. I'm thinking it's going to be skewed because the next one's going to be normal for question 4. So I'm thinking it's going to be skewed one of the ways.
So I'm going to put skewed right for number 3.
Yeah. That's what I'm guessing too.
Okay.
It should follow kind of a similar pattern. And then 4, when you take in the shape of the distribution. Yeah, 4, I would put normal as well. Question 5, when you're taking a sample size of N5, what is the shape of distribution of means histogram when the parent population is normally distributed?
I would say it's normal.
Yeah, it's normal. That was like one of the rules, right? Like, doesn't matter how big, as long as the parent population is normal, then the distribution of means will be normal as well, correct?
Yeah.
Yeah. So number 6 is the same question with 100, which would also be normal, correct?
Yep.
Yeah.
Okay.
7, when would the distribution of means be normally distributed? Choose all correct responses. 1 says data are drawn from the population that is normally distributed, and the sample size is small.
Yes.
Data are drawn from what, Matt?
No, I was yelling and saying yes at the same time. Sorry.
Oh,
you guys are boring. No, I'm kidding.
Okay. Data are drawn from the population that is normally distributed and the sample size is large.
Yes.
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 Data are drawn from the population that is right skewed and the sample size is small.
No.
No.
I would,
because if we put question 3, we would have put normal.
Right.
So, but if it's large, then yes.
Yes. Yeah, because the larger it gets, the more towards normal it gets.
Correct.
That's right. Okay.
So A, B, and D.
Okay. All right. Which of the number 8? Which of the following gives the best explanation of the central limit theorem? If the parent population data are drawn is normally distributed, then the sample mean X will follow a normal distribution. Okay, that's true, isn't it?
Yes.
Just to be sure. A bell-shaped data, approximately 68% of the data will be within 1 standard deviation of the mean. About 95% of the data will be within 2 standard deviations of the mean, and approximately 99.7 data will be within 3 standard deviations of the mean. Okay?
I don't think that has to do anything with the central limit theorem.
No.
That makes sense. That's what we were reading last time.
Right.
The sample size is large. If the sample size is large, the sample mean X will be close to the population mean.
That is true, but that's the large number.
Large numbers rule.
If the sample size is large, the shape of the distribution and the sample mean may be approximately normal. Yeah, I still think it's A.
Right. Same.
Okay.
So actually, hold on. Guys, real quick, in number 8, so the reading says like the only reason I'm pausing is for option D. The reading states approximately normal for the central limit theorem. It says if a sample size is large, that it will be approximately normal.
Okay.
So that's the only reason I would pause for a second, because it says
It said that flat out.
It doesn't say anything about the way that the parent
population.
Yeah, under number 5, the law of large numbers, it says the central limit theorem states that if a sample size is large, the x will be approximately normal.
Okay. Yeah. Okay.
Okay, yeah, in the summary as well, it says the distribution of sample means is normal when X is normally distributed, or when, thanks to the central limit theorem, our sample size N is large. So that one. Yeah, good call. I would put D then as well, because it talks about the sample size and not it being normal distribution.
It talks more about the size versus the actual mean.
Right.
It says approximately normal versus following a normal distribution.
Right.
So, all right. We ready to move on?
I think, yeah.
Okay. Number 9, use the following information to answer the next 4 questions. Let X be a random variable with a population, the little U sign equals 10, and a population standard deviation. And that's the mean, right? 0 equals 6.
Yeah.
Suppose the sample size. Wait, go ahead.
Sorry, the U is the mean, right? Oh, yeah, never mind. Keep going.
Yeah. 10 would be the mean. Standard deviation is 6.
Right. And suppose the sample size N equals 36 is drawn from this population. What is the mean of a distribution? What is the mean of the distribution of sample means? It'd be 10, right?
Correct.
And the standard deviation would be 6.
And then what is the standard deviation? No, the standard deviation would be
that formula.
That formula, exactly. It'd be 6 divided by the square root of
1.
36. Right?
Yeah, 1.
It'd be 1, right? Because 6 divided by the square root of 36 is 6, which is 1.
Right.
And then 11, regardless of the distribution of the population, if the sample size is large and is greater than 30, what would be the sample distribution of the sample mean? And that's normal, right? Greater than 30?
Yes. Yep. Because it asks what the shape is of the distribution of sample means. And so, yeah, it'd be normal.
Okay. Okay. What theorem would justify your response to the last question?
So it would be the law of large numbers, right? Law of large numbers states that as the sample size N gets larger, the sample mean X will get closer to the population mean. No, that's
no, because it says no. I would say it's the central limit because it states that if a sample size is large, it'll be approximately normal.
Yeah, the reading said that those two were going to get confusing, but according to what we put of the central limit theorem, that it's depending on the size that kind of justifies if it's a normal, if it's a shape normal or not. So I'd put central limit theorem as well.
Cool. Good job. We got 14 out of
4. Hey.
Let's see here. Mine is still thinking.
Yeah, mine too. Taking forever. Yep, cool. Cool, guys. Well, I will see you on Wednesday then.
Yeah, I'll be there. Everybody have any questions? Are we all good?
No, I think that was pretty good.
Cool. I'll send you guys a link and I'll post it on the discussion board.
Sounds good. Thank
Sounds
you.
good.
Have a good night, guys.
All right. See you guys.
Good night.